So last time we were talking about the logarithm function, and it is the one function that gives you the area under the curve of the function 1 over x. Okay, well, I want to talk to you about an inverse function of the log. That's why we spent so much time doing the inverse functions. What I now want to talk to you about is the inverse function called the exponential. All right, so let's recall for a moment. The function, the log of x. It is the integral from 1 to x of 1 over t dt. So what we did was we graphed the function one over x and we said the logarithm function is the function that gives us the area under the curve from a value 1 up until x. Okay, so there's one number, and that number is e. So if I do the integral, sorry, if I find the area from 1 to this number called e, that is the integral from 1 to this number e of 1 over t dt, that integral is 1. All right, so from 1 to e, the area under the curve is 1. So the question is, well, what in the world is e? So e has been determined to be 2.718281828 459045, and it keeps on going. Okay, so most times you will see 2.71828 is E. All right. Another way of writing this number E is the limit as n goes to infinity of this sum, 1 plus 1 plus a half plus 1 over 3 factorial plus 1 over 4 factorial plus ... plus 1 over n factorial. So if n goes to infinity, that's another way of approximating this number e. So e is the only number such that the log of e is equal to 1. That is, that integral is equal to 1. Now, why is e so important? Okay, well, we can create what we call the function called the exponential function. And this exponential function is y, or f of x, is to take this number e and raise it to the x power. Okay, so what does that mean? Well, e to the first power is e, I want e squared, just means take e and multiply it by itself again, okay? What is e to the minus 2? Well, that just means do 1 over e squared, so you can calculate that. And so what is e to the 1/3 power? Well, that's just the cube root of e. So all of these have values that you can calculate on the calculator. So now what does f of x equal to e to the x look like? All right, well, let's start off by doing some quick calculations first. So let's suppose I have this, and I tell you x, and I want you to calculate e to the x. So if x is -1, then e to the -1 is simply 0.37 and some other digits. Okay. If I tell you that e to the 0, well, we know any number to the 0 power is 1. E to the first power, we already know that e to the first power is that 2.71828 number. Probably should have given you some more numbers on e to the -1, but it's okay. E squared is approximately 7.39 and some more decimals. E to the 10th, well, that number gets pretty big. So that's 22,026. And let's say we get really excited and we go to compute e to the 100th power. And that number is 2.6881 times 10 to the 43. So as you can see, these numbers are blowing up. That is why this is called the exponential function. So the exponential function e looks like this. Starts off very small. E to the 0 is 1. And then this function blows up very quickly. Okay, well, here's the fun part. We already talked about the logarithm function. The logarithm function looked like this. It went through 1, and then it was kind of flat. Well, guess what? The log function and the exponential function are inverses of each other. So the natural log of x and e to the x are inverse functions. So now there was one thing that I said to you when we were talking about inverse functions. We said that f inverse of f of x equaled x. And we also said that f of f inverse of x is equal to x. So as these things are inverse functions of each other, we get that the log of e to the x is simply, well, let's think. Remember, the logarithm property said that whenever I had something to a power, I could bring that thing down as x times the natural logarithm of e. But remember, e is the only number whose natural logarithm is 1. So this becomes x times 1. So I get x. So as you can see, e to the log of x gives me x. I'm sorry, I ain't got that far yet. Log of e to the x is just x. And the other property is if I take e to the natural log of x, that is also x. So these are inverse functions of each other. Okay. All right, so what are some properties, okay, or some examples of how to use this? So here's some quick examples. Well, let's suppose I take the log of e to the fourth power. Well, that is the log of e to the x is x, so the log of e to the 4 is 4. Done. Number 2, the log of e to the 1/2 is simply 1/2. Same as the log of the square root of e is the natural log of e to the 1/2 is 1/2. The natural log of e to the -5 or -5 is -5. It does not matter what it is. This is the way it works. The natural log of e to the tangent of x. Well, you didn't say anything, Dr. Lott, about e to a function. It doesn't matter what's in the exponent. The natural log of e to f of x is also f of x. So this is the tangent of x. So note, the natural log of e to u of x is still just u of x. Okay, so let's go the other direction. E to the natural log of 6. Well, that's e to the log of x. So that's x. So that's just going to give me 6. E to the natural log of the sine of x is the sine of x. This is where life can get difficult. E to the 4 times the log of 2 right now I can't simplify it because it's not e to the log, but remember 4 times the natural log of 2 is the same as the natural log of 2 to the 4th. And that's just the log of 16. So this becomes e to the natural log of 2 to the 4th, which is equal to e to the natural log of 16, which is 16. And I feel like my numbers, why do I feel like I counted wrong? Because I did 1, 2, 3, 4, 5, 6, and then I did 5 again. Okay, that's not real smart. Okay, I'll give you a minute to do those. and then we'll go on. Okay, anybody want to give me an answer?
For the first one, I got 1 plus cosine x.
Okay, 1 plus cosine x. Thank you very much. Okay, another willing participant. You want to give me an answer?
It's x squared.
Okay, it's just x squared. All right, so although it looks crazy, all right, remember anytime you have log and e next to each other, you get the exponent e to the log, you always get what its argument is. Okay. Suppose we need to find y. So here, let's another example. Let's find y if the log of y is equal to 4t plus 2. Okay, well, one of the things we can do is what a student of mine said, let's e it. We can make that that should not be equals, that should be if. Another student of mine said, well, if that's the exponent, then life is easy. I can take e to the natural log of y and get e to the 4t plus 2. And so e to the log of y is y, so y then becomes the exponent e raised to the 4t plus 2 power. Okay. Find k if e to the 2k is equal to 7. Take the natural log of both sides. Log of e to the 2k, the natural log of 7. On this side, I just get 2k is the natural log of 7. So therefore, k becomes 1/2 the natural log of 7. Nice, simple problems. Okay. Lastly, if something has the same base, all right, if something has the same base, then their exponents have to be equal. So find k if e to the 2k is equal to e to the k plus 1. Well, that means then that you take the natural log of both sides. So I get the natural log of e to the 2k is equal to the natural log of e to the k plus 1. So now I get 2k is k plus 1, and that implies that k is equal to 1. Okay, so we can use laws of exponents to help us simplify things. This should be a review for you. So we already did the law of our logarithms. So now let's look at the law of exponents. So the first one is e to the a times e to the b is e to the a plus b. So you just add the exponents. It's the same way as when we did x squared times x to the fourth became x to the sixth, e squared times e to the fourth becomes e to the sixth. Okay. It also works to break things up. So we can simplify e to the x squared plus the natural log of x as e to the x squared times e to the natural log of x. But the e to the natural log of x, that little thing just becomes x. So this is x e to the x squared. Okay. E to the a divided by e to the b is e to the a minus b. So e to the x squared plus 1 divided by e to the 2x just becomes e to the x squared minus 2x plus 1, because I take and I'm subtracting off my 2x. Okay. E to a power and then to another power says multiply them. So that's e to the AB. So e to the fourth raised to the x power is just e to the 4x. And e to the x raised to the log 3 power is simply e multiply them to the x times log 3, but they're multiplied so I can switch them to e to the log 3 raised to the x power, and e to the log 3 is 3, so that just becomes 3 to the x. And we will use that, okay? You will use that a lot. E to the 4 log x. Okay, well, that becomes e to the log x raised to the 4th power. So e to the log of x is just x, so that's x to the 4th. I think that's what I want y'all to do. Oh, nope, that's not right. Let me redo it on paper and then I'll get it right. I want E. Okay, now you can do it. I think. Yeah, that's right.
Professor,
Yes.
how did you get e to the third for number 2?
So for this one, I want you to solve for X for this one. And the second one, I want you to solve for X. I should have said that. Okay, any takers? For number 1? How do you simplify number 1?
Would you have to would it be e to the 4x plus not plus e
Oh,
to
you
the
know
4
what? Wait a
to
minute,
the
you're right.
nat
I forgot a plus. You're right. I
okay.
forgot a plus. You're so right. Thank you very much. I know what my brain was thinking, but I didn't write it. This is supposed to be plus log of X. Okay, now go ahead.
So it would be e to the 4x times e to the natural log of x.
I want you
Which
to keep
then
going.
would equal
What is this term?
wouldn't that just change to x?
Yes.
Well, I don't know how to put it, like e to the 4x. Oh, okay. Times x.
Okay, how do you solve for X in the second one?
Oof. So I had I guess you could say had simplified. Well, I didn't simplify, but I had changed it to e to the x squared minus 2x plus 4, and then I had stopped there.
Has to equal E cubed.
Right.
So what do you know about then take the log of both sides. Is equal to E, whoop, the log of E cubed. So X squared minus 2X plus 4 is equal to 3. So what does that say? X squared minus 2X plus 1 is equal to 0.
Where did you get 1 from?
I subtracted 3 from both sides.
Oh, okay.
Okay. And then this is x minus 1 squared. So x is equal to 1. Okay. Now, here's the thing. Exponential is a special function. So f of x equal to e to the x is very special. It is the only function that exists whose derivative is equal to itself. It's the only function whose derivative is equal to itself. Okay? So let's see, how do I figure that out? Well, let's solve dy dx is equal to e to the x. This is Calc 2, right? Okay. I'll prove it to you later when we get to, I'm trying to remember, did you guys learn this yet? No, you did not. Okay. The solution to this is y is equal to some constant times e to the x. Okay. So this is what we get. Say y is equal to e to the x. I want to use logarithmic differentiation to find its derivative. So let's take the log of both sides. Okay. And so now I get the natural log of y, and the log of e to the x is just x. So now let's take the derivative of both sides. So now when I take the derivative of the log of y, I get 1 over y dy dx. And the derivative of x is just 1. So now let's multiply by y. So I get dy dx is just equal to y. So I thought I made a mistake up here. This is wrong. This is supposed to be a y. Go back and make that a y. So now I get, what do I get? So I was trying to solve to see which function where its derivative of y is equal to itself. So I have the derivative of y is equal to y. I want to show you that that's going to tell me that it's the exponential. So we're going to start off and figure it out. So now I end up with the derivative of y is equal to y. But what was y? Y was e to the x. So if y is equal to e to the x, its derivative is e to the x. All right, so now we know a couple of things. We learned that the derivative with respect to x of the natural log of x was 1 over x. And now we know that the derivative with respect to x of the function e to the x is e to the x. Okay, so those are the two major things that we've learned so far in this section. But there was another really important thing. We learned that the derivative with respect to x of the natural log of u of x, what was that? Anybody remember? We took the derivative of the function with respect to u and got 1 over u of x, and then multiplied by its derivative. So if I take the derivative with respect to x, of e to the u of x, well, that says, well, the derivative of e is that, so I'm going to get e to the u of x. But just like the chain rule, I have to multiply by the derivative. So these four are how to take the derivative of the natural log and the exponential. Okay. Okay. One, derivative with respect to x of e to the x is e to the x. Number two, the derivative with respect to x of e to the 2x. Well, here, u is 2x, and du dx is 2. So therefore, the derivative with respect to x of e to the 2x says I just get e to the 2x, but I have to multiply it by du dx, so I get a 2. So I get 2 e to the 2x. Derivative with respect to x of e to the x cosine x. Oh, let me do one easier than that first. E to the sine x. Well, I'm going to get e to the sine x and then multiply by its derivative. So this is going to give me cosine x e to the sine x. Okay, now derivative with respect to x, e to the negative x. What is that?
Will it be negative e to the x?
Okay, good. So I'm going to get e to the negative x, but the derivative of negative x is just -1. That's it. Okay, I want you to work on those 3. Okay, Alan, have you finished the first one?
I'm still working on it as well.
Okay. Lawrence, have you finished the first one? Or the second one or the third one?
No, I'm still working on it.
Okay.
Professor, can you scroll down up a little bit?
You mean to the other examples?
Yes, thank you.
You're welcome. Okay, Juan, which one did you think you want to tackle?
The first one.
Okay. What
And
would you get?
well, I got EX over X.
Okay, so you did, what rule did you use?
started out by doing the derivative of
So you did the derivative of the first, good, and you got 1 over x times the second.
Yeah.
Plus, then what did you get?
The second one was derivative of ex, which is just e to the x.
Times. You still have to do times the first. The derivative of the first times the second plus the first times the derivative of the second. Okay. So you factor e to the x out and you get 1 over x plus the natural log of x. Okay, very good. All right. And what's difficult about this second one?
I don't think multiplying the first function with the second derivative and the second derivative of the first function works with this one because I got a different answer.
Okay, so for this one, remember, what is u of x here? U of x is x cosine of x, right? So you have to
Yes.
find du dx. And what is that? You have to use the product rule for that. So that's the derivative of the first times the second plus the first times the derivative of the second. So now I just say that this is the derivative of e to the u is e to the u, but I have to multiply by du dx.
Is it sine x e to the x? Oh, no.
Okay, who's talking?
Oh, that's me, Ezekiel.
Okay, so Ezekiel, you just take e to the u and you write e to the u as it is. So this is e to the u. You just write as e to the u. And then you have to multiply by the derivative of u. And the derivative of u is the product rule. And the derivative of u gives you cosine x minus x sine x. There is no exponential with the sign at all.
Got it. Thank you for the correction.
No problem. Okay, so in the second one, the third one, what is u? Well, u is negative 5x, so that's okay. I'm gonna use the product rule again. I'm gonna get the derivative of the first is 2x times the second, e to the negative 5x, plus the first, which is x squared, times the derivative of the second, which is negative 5, e to the negative 5x. So this simplifies, I can pull out the e to the negative 5x, and that leaves me 2x minus 5x squared. Okay. Any questions?
I'm just curious as to why it is negative 5 into the negative 5x, and I had thought it was negative 5 e to the negative 5.
Okay, so you're curious as to why it's not negative 5, it is negative 5 e to the negative 5x. So when you took the derivative, so I did the derivative of the first times the second, which is e to the minus 5x, plus the first times the derivative of that. So the derivative with respect to x of e to the negative 5x is negative 5 e to the negative 5x. So that went in here. And then I just simplified. I was able to pull out e to the negative 5x out of both terms. Eric, does that make sense?
Yes.
Okay. All right. So everything that we have done thus far has been based on logarithm base e. Okay, so logarithm base e. So what do I mean by that? Well, when we have f of x equal to e to the x, its inverse function I'm gonna call it g of x. And it's actually the natural log of x, but the natural log of x truly means logarithm, but we're using base e. And so this is the notation that we use. So whenever you see ln of x, that means the base that we're using, the logarithm, is base e. Now, if you recall, log of x is actually logarithm base 10 of x. And so you guys may remember logarithm base 10, that's what they use, the Richter scale, you know, log base 10 of x and all of that. That's what they use. Okay. Well, its inverse function, so log of x equal to, well, I already wrote that. This function has inverse function equal to 10 to the x. So we actually end up with something that looks like this. I can have any base a and this is f of x is a to the x, and a is greater than 1. And then I can have its inverse function g of x equal to log base a of x. So now I have two new functions, not necessarily using e, but now I'm just using some number a. Okay, I'm just using some number a. All right, so these are inverse functions. All right, so let's talk about, good Lord. Okay, let's talk about the natural log first. Okay, so the natural log, I'm sorry, not the natural log, log base a. So let's consider the log base a of x. So suppose your calculator doesn't have the log base a. Your calculator has ln, which is log base e, and your calculator has log, which is log base 10, but it doesn't have log base 5 of x. Well, we can write the log base a of x as the natural log of x divided by the natural log of a. So that's the definition. Okay. So the log base 4 of x is the same as taking the natural log of x divided by the natural log of 4. And the natural log of 4 is a number. We can put that into the calculator. All righty. So how do you take the derivative of it? So if f of x is equal to the log base a of x, then the derivative with respect to x of f of x is the derivative with respect to x of the log base a of x. But that's the derivative with respect to x of the natural log of x divided by the natural log of a. But the natural log of a is just a number. So I can pull it out as 1 over the natural log of a, and the derivative of the log of x is 1 over x. So there's my new rule. That is the derivative with respect to x of the log base a of x is 1 over x, the natural log of a. So the derivative with respect to x of the log base 6 of x is 1 over x natural log of 6. And the derivative with respect to x of the log base a of u of x, oh my goodness, you threw that u in there, Dr. Lott. Well, that's going to give me 1 over u of x, the natural log of a, times du dx. Okay. Example. Given f of x is equal to the log base 7 of the sine of x. Find df dx. Find its derivative, or f prime. Well, here, u of x is just the sine of x, and du dx is cosine x. So therefore, these 3 dots, I haven't used this yet, but these 3 dots mean therefore f prime of x is 1 over u of x is sine x times the natural log of 7 times the cosine of x. So this becomes the cotangent of x over the natural log of 7.
Dr. Locke, you
Yes.
cross multiplied sine x, yes?
Cross multiply.
Sine x, 1 over sine x times natural log of 7 times the cosine of
Yes.
x.
So then what I did was I just made this the cosine of x over the sine of x times natural log of 7. And then I put these two together to give me cotangent.
Okay.
Okay. Okay. Last formula. So recall I can write a to the x as e to the natural log of a to the x. So that is e to the x times the natural log of a. So therefore, the derivative with respect to x of a to the x is the same as the derivative with respect to x of e to the x times the natural log of a. But that's just e to the x times the natural log of a. But I got to take the derivative of the u, and the derivative of the natural log of a times x is just the natural log of a because it is a constant. But e to the x log a is a to the x. Okay. So therefore, get two more rules, and that is the derivative with respect to x of a to the x is a to the x times the natural log of a, and the derivative with respect to x of a of u of x is equal to a of u of x, natural log of a times du dx. And that is every formula from this section that needs to be known. Okay. Please, please, please look at the examples in the online text. There are numerous examples in the online text. If you are struggling and you want extra help, do some of the problems at the end of the section in the online text. It will help you. The more you practice, the less you have to worry about being stressed on the exam. These formulas, once you continue to work with them, become natural. Okay.